Hello everybody and welcome back to more of the 2016 Canadian Senior Mathematics Competition, the Csmc, and we're up to question number 5. Gary and Deep play a game in which there are no ties. Each player is equally likely to win each game. The first player to win 4 games becomes the champion, and no further games are played. Gary wins the first 2 games. What is the probability that Deep becomes the champion? Okay. Probability that Deep becomes the champion. Interesting. So it's a probability question, and you might think, hey, we could make a probability tree. And I seem to recall when we were marking this, a lot of people made a probability tree, but they did not understand how to do things like conditional probability. So what I'm saying is, there's sort of, if we're going to make a probability tree, there's 2 things we can do. We could already say, okay, Gary won 2 games, so we're making a probability tree starting with the 3rd game. And then, okay, does Deep win or does Gary win, and so on. But we stop as soon as Gary wins 2 games because he's already won 2. And that's fine. I think that's the better way to do it. But some people will want to say, okay, no, if you're going to make a probability tree, you've got to start from the first thing. So, could Deep win the first game or the second game? Well, no, he can't win either of those 2. Why are you including them in your probability tree? Because this is what you've been trained to do, and you don't quite understand how to use conditional probability or how to start off a tree further down the line. And so, as I recall, we got a lot of really big trees when we were marking this question. And then, I'll stop it here, but people would say, okay, these are all the branches where Deep could win, ignoring that they were counting branches where Deep had won 1 or more of the first 2 games. Okay, if you're going to do this, you can only ever consider branches that start off GG. So you don't need to draw any more of this. You can essentially just start drawing at the 3rd branch, okay, for the 3rd game. Okay. If you're going to do that, you have to use Bayes' theorem and a whole bunch of other probability stuff that I understand is not exactly native to high school students, certainly not grade 11s. Most grade 12s, I find, also don't really know a whole lot of deep probability stuff. So what I would do is I would just start off with the 3rd game. We say, okay, yes, Gary won the first 2 games. He only needs to win 2 more. I'd probably make a note of that somewhere. And then say, okay, now who wins the 3rd game? What are the chances that Deep wins it? Does he start making a comeback, or does Gary start solidifying his lead? That sort of a thing. So I will make the observation that G wins after 2 more games. So our 3rd game, Deep could win, but so could Gary. And this happens with 1/2 probability each time. I wouldn't even bother writing it down that much, because you're going to just have a whole lot of halves everywhere, and it's going to be quite messy. So our 4th game. Well, Deep could win that, or Gary could win it. Or Deep could win it, or Gary could win it, but, and I would make sure to write this down, at this point, Gary wins. No more games. Okay, so we don't have to go off of that branch anymore. How about the 5th game? Well, Deep could win it, or Gary could win it. Deep could win it, Gary could win it, but that's assuming the 5th game is played, which it isn't down here. I'm actually going to shift these a little bit to start filling in the gap. So Deep could win, or Gary could win. Deep could win, or Gary could win. Okay? But look here. Now we have Gary has won 2 more games. So Gary wins here. And Gary wins here, because there's 1 Gary win, 2 Gary wins. Okay? And now up here we have 1 Gary win. So here we have the 6th game. Well, Deep could win, and then he'd finally have his 4 wins. Yay! He won. Or Gary could win. Or Deep could win, or Gary could win, but then we're going to stop because Gary's won all his games. Deep could win, Gary could win, nothing else to do here. Deep could win, Gary could win. And once again, we will stop because Gary has won. We will stop here because Gary has won. And now Gary has won. And finally, our 7th game, well actually no, we don't need to do that one because Deep has won at that point. So I'll use purple for Deep wins, which we haven't seen many of. So Deep could win this last game, or Gary could win this last game. And we're only going to go up to 7 games. Because the second you have 8 games, you'd have to have someone who's won at least, or well, second the 7th game is played, at least someone has won 4 games. It's either 4 and 3 or 5 and 2, that sort of thing. So here's a Deep win. Deep would have to, all of these Deep wins will have to be the final person who wins. So these are all Gary wins as well. Okay. So there we go, and now we have to start assigning probabilities. Okay, there's our complete tree, because remember, games stop being played as soon as somebody has won. So we need to assign probabilities to these branches and add them all up. So the nice thing is, with all the probabilities being 1/2, just multiply along the branches. So Gary makes this win 1/4 of the time. He wins after the next 2 games 1/4 of the time. He wins here 1/8 of the time. He wins here 1/16 of the time. This is 1/32 of the time. Deep's win down here 1/2 plus 1/2 plus 1/2 or times 1/2. So we got 4 1/2s, 1/32. All the wins here at the end are going to be 1/32s. But we don't actually need to figure out the Gary wins. We just need to work with all the Deep wins. And so our only other Deep win is this 1/16. So we'll add up the Deep wins probabilities. I will finish these off just for the sake of completeness. 4th branch in the or four branches deep, they're all going to be 1/16 of a probability. So our Deep wins are 1/16 plus 1/32 plus 1/32 plus 1/32 plus 1/32. So 4 1/32s, and that'll be 1/16 plus 1/8, and so that'll be 3/16, and that's the probability that Deep can win, assuming that Gary has won the first 2. Now the probability that Gary wins is going to just be 13/16. Okay, but notice, first of all, we chose the shorter tree to create. If we'd started with that 1st and 2nd stuff, we would have had a whole bunch of unnecessary things. We also remembered the rule: stop making more games if Gary has won. Stop making more games if Deep has won. Those don't count for probabilities. Okay. So, as I recall, this question was very poorly done in terms of probability. It's been a long time since we marked it, so I can't remember any of the specifics of people having a lot of trouble. I just remember there were a lot of probability trees that were very poorly made, and then there was some very poor understanding. Like, more than a few people said, oh, it's equally likely that they'll win any given game. It doesn't matter that Gary's won 2, it's still equally likely that Deep could win, so 50%. There were a lot of those. And that just demonstrates very, 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 very poor understanding of probability. You know, that's like saying, you know, there's a 50-50 chance that the Earth will blow up tomorrow, because either it'll happen or it won't. You know, it's that level of terrible. And so I would recommend to anyone who had even the slightest hesitation practicing this one, or, you know, trying this, or, you know, doing this one in the actual 2016 year, to go brush up on your basic probability. Okay? Because that, you know, that was an eye-opener when we marked this, is that people are really bad at probability. Okay? I'm not going to dwell any more on this question. We're going to move on to our next, and I think it's the last question in Part A. Yeah, so that was question 5. Now we're going to go on to question number 6 in the next video. I will see you guys there, as we are going to take a look at Moffat numbers, whatever those are. I'll see you guys for that next time.